So we have covered until this slide in the last class till assignment operators, and we'll start with conditional and comparison operators today. So if you can see this, right, this is double equal to. So generally, if you have a single equal to, that is assignment. When you say like a equal to 5, that means we are assigning the value 5 to the variable a. But when we write double equal to, that means it is used for comparison. Double equal to means if we say A double equal to B, that means we are basically comparing whether A is equal to B. So that's a comparison, and that is not an assignment. So similarly, when we have like this exclamation and equal to mark, that means that not equal to operator. So in front of equals, we are just placing a exclamation, and that is a not. This exclamation basically is a not and equals. So this entire exclamation equal to is like not equal to operator. Then these are like simple ones like opening bracket. This is less than operator. Then we have like greater than operator. Then again we have less than equal to operator, then we have like greater than equal to operator. Let me show these things with an example. Let me go ahead and create a class that will be named conditional operator. Let me create that main method here. And I will show these examples with some kind of if-else block. If-else block we will discuss if-else block we will discuss in great detail in some in maybe today's class or next class, but I'll just teach you how we basically see the usage of these operators. Let me create a variable a, assign it to value, assign value 10 to this. Let me create another variable b, assign value 15 to this, and we want to make some comparisons on to this one. So basically, we can use if-else statements for making comparisons. So the syntax for this is if some condition and we have a opening curly braces and we have a closing curly braces. So from line 8 to 10, we basically have a if block. So see, if this condition, whatever condition I'm writing here, this is simply I'm just trying to let you know the syntax. So this is basically like syntax of if condition. So if this condition is true, so our control of the program will go inside this curly brackets. So here we can have some kind of like statement written, some Java statement which we want to execute. So let me go ahead and remove this. I'll basically write down some. One second. Last class, we also saw how we write down multi-line comment, right? So I'm writing down multi-line comment, forward slash, asterisk, and then where we want to like conclude our multi-line comment, there we have written asterisk, forward slash. So this part of the code from line number 9 to line number 13 is commented. So we basically, so whatever things we basically comment out, that is used for documentation purpose, and those statements will not be executed by the Java compiler. So basically, if some piece of code you have commented, that will not be executed by Java compiler. Let me go ahead and show you the usage of those operators. See, if A equal to B, then I'm printing out something like A and B are equal. Let me try to run this program. See, we did not see any output here, right? The program ran, but we did not see any output. Why? Because A was having the value 10, B was having the value 15, and if A equal to B, then we were supposed to print system.out.println statement, but A and B are not equal, so we did not execute this statement. Now we have like other statement. We are basically writing another condition. If A not equal to B, do you see this exclamation equal to mark? This shows not equal to. And now A is 10, B is 15. And we are writing down the condition if A and B are not equal. So basically this should run this statement, right? Let me go ahead and again run this program. Basically this should be not equal. See, if A and now we are getting the output like A and B are not equal. Everyone can see this? Hello?
Yes, I see that.
Yeah, and you are able to follow this, right? This is very straightforward. We are
Yeah,
basically declared two variables and initialized them with values 10 and 15. So A is having value 10, B is having value 15, and we are basically writing down this if statement. So this if statement, we already saw the condition syntax, right? This is if is a Java keyword. So basically we use if and else blocks. I will talk about else blocks in the uh, in today's later at some time or in the next class. So basically if when we provide this condition, if this condition is basically true, if this condition is true, then whatever is between these curly brackets, whatever statement we have written between these curly brackets will be executed. Otherwise, this will not, the control of the compiler won't go in between these curly brackets. Everyone able to follow this until now? If anyone has any doubts, please let me know now about this. Now we go ahead and see like if A is less than B, then we would just go ahead and print A is less than B. Now this is another if statement I have written, and I'm using another conditional operator, like if A is less than B. So basically if I run this program, we know that A is less than B, right? Because A holds the value 10, B holds the value 15, and this should basically be a true condition because A is less than B. So this should basically go within this condition. This condition is basically true. So the control should go in this line number 19. Let me try to execute this program. So you can see the second statement printed, right? A is less than B because this condition is true. Similarly, let me create two more variables. Int x equal to 20 and y equal to 20. If x is less than equal to y, x is less than or equal to y. This is what I want to basically print. Now let me run this. So it ran this as well, x is less than or equal to y. So basically in line number 25, we have two conditions, whether less than or equal to. So if x was even less than y, so basically if we now alter the value of x to like 15 as well, so even then this condition would be met, right? X is less than or equal to y, because x can be less than y or x can be equal to y. So if any of these conditions is true, basically this statement would be executed because this condition will be true. So this is less than equal to operator. Similarly, you can practice like greater than equal to operator as well. And then there are this few, yeah, greater than equal to, less than equal to. These are like other operators you can practice on your own. And these are like straightforward, very simple operators, conditional and comparison operators. So next we would go ahead with logical and Boolean operators. So Boolean operators are basically, uh, if you want to basically have two conditions, if you want to basically check two conditions in your Java program, you will go ahead with a Boolean operator. So I will show you how basically we use Boolean operator. Let me go ahead and create another class for Boolean operator. Let me go ahead and create that main method. Now, let me show you what's the syntax of Boolean operator. So syntax of Boolean operator is basically double ampersand. So you have this ampersand symbol. So you write two times ampersand together. So basically this is the example of Boolean operator. So Boolean operator will always like return me some value like true or false. So let me go ahead and try to demonstrate this example for you. Int x equal to 15, int y equal to 20. So basically I've created two variables and assigned some values to that. Now, so there's another data type that we studied, right? There was one data type named as Boolean. So which holds the value like true or false. So let me try to demonstrate like what we basically how we can see the use of Boolean operator and also like Boolean data type. Let me create two more variables, int a equal to 10, int B equal to 12. Let me now write down the conditions. We have already seen how we write down if statement. What we basically do, we basically write the keyword if, and within this brackets, small brackets, we basically write down the condition and then write down the curly brackets. And within curly brackets, whatever statements we want to execute, we basically write down those Java statements. So what I want to basically demonstrate is like how we use this double ampersand Boolean operator. So this we will write basically two conditions here. One is, so for the first condition, I have written one pair of brackets here. We will write first condition here, and what we'll basically do is like this is condition 1, and this will be basically condition 2. And then if both these conditions are met, so we would execute the Java statement at line number 16. So ampersand basically tells you this double ampersand will basically be used when we want to like write down two conditional statements. And if both the conditional statements are met, then it would like return true. So let me replace these conditions with some proper meaningful statements. If x is less than y, and a is less than b, so I'm creating one Boolean flag variable. So Boolean flag variable I've just created. So basically, I'm initially assigning this to false. So now what we basically do is like if x is less than y, if condition 1 is true and a is less than b, condition 2 is true, then we would basically go ahead and create and like reassign the value true to this particular variable. And when we come out of this loop, we basically want to like print the value of flag. We want to basically see whether the statements that we have written is basically whether both the conditions that we are written are basically true. So let me go ahead and execute this program. So you can see that you're getting the output as true in this case, right? So what basically happened? We have created four variables x, y, a, and b, and we have assigned some values to them. And then we have one data type, Boolean flag, which is initially assigned to, which is assigned the value as false. Now, when I go at line number 17 to 19, what this basically is, this is a if block statement. Just write down here, if block, if so this is basically a Java if block. And what we basically write in this is the if block will have some conditions. If that condition is true, basically the statements within that block will be executed. If those statements are not true, then that block will not be executed. So in this condition, in this case, we basically can see like if x is less than y, that is true, right? 15 is less than 20. So this first condition is true. And a is less than b, yeah, 10 is less than true. 10 is less than 12. So basically that condition is also true. So we are basically the control will go to this particular statement at line number 20. So the flag equal to true and the value got reassigned. and both the conditions are true. So that is why we were able to execute this particular uh, statement, and we got the output as uh, true. Now let me show another thing to you. Okay, in this example only, what I'm trying to show is like I will make the x value as 25. What do you think now will be the output in this case? Can you please let me know whether this will be true?
So, sorry, can you try your question? Sorry.
Yeah. So I have a question like I've changed the value of x from 15 to 25. Now can you tell me in the print statement at line number 23, what will be the output? Will it be true or will it be false?
I think it's false, right? Because one of is false.
Yeah.
Is
So
false,
yeah. So basically x will be like now x is like greater than y, right? Because 25 is greater than 20. So this first condition will be false, right? If x is less than y, this condition itself is false. So I'll tell you one more thing. So how Java compiler works is like when we are using this double ampersand uh, sign. So this is like Boolean operator sign. So now if this condition is false, so if x is less than y, so at this point of time only, we basically saw that this condition is false. So it will not even go and check this condition. The Java compiler won't go and check this condition because this ampersand, double ampersand, or Boolean operator is basically checking whether both the conditions are true, even condition one and condition two are true. Only then we basically go and execute the statements. So in this case, when your first statement itself is false, it does not even go and check the second condition. So when the control Java compiler control will come until this point. So basically it will check like if x is less than y, this returns me false. So this won't even go to this condition and then it will come out of the loop. So in whatever initial value of the flag was false. So it will basically return me that. Let me try to execute this. We are getting the value as false, right? Now there is another operator, I will say. This is like Boolean operator ampersand. This is like we basically call this as this operator is also called like logical AND. Logical AND operator. Now we would see the demonstration of logical OR operator. So logical OR operator is basically represented by double pipe symbol. Above you in your keyboard, basically above that backward slash, on top of that you have this pipe symbol, right? So if you like use it two times, this is called as logical OR operator. So if I try to like just remove this ampersand with this double pipe sign, so this is basically logical OR operator. So why we basically use this operator is like it will also return me a Boolean value, and we have two conditions, right? If x is less than y and a is less than b. So we saw earlier that double ampersand only returns true when both the conditions are true. So now we have this logical OR operator which will return true even if one of the conditions is true. So now you can see this. If x is 25, y is 20. So we go ahead and check this condition. If x is less than y. So this is false, right? Because 25 is not less than
Which is
20.
true.
20, no, means 25 is not less than 20, right? 25 is greater than 20. So what I'm basically checking is x is less than y. So 25 is less than 20. What do you say? This is false, right?
Mhm.
Yeah. So this is false, but we are using a logical OR operator. So logical OR operator will, so we'll check another condition. If A is less than B, which is correct, right? 10 is less than 12. So this is basically true. So in logical OR operator, the Java statement within these curly braces will be executed even if one of those is true. So if one of those conditions is true, so first condition was false, second condition was true. So even if one of the conditions is true, this will basically return true. So if I go ahead and let me just comment this one out. So we are basically running just the logical OR operator now. So if I just go ahead and execute this, okay, what basically, one second. Yeah. So you can see that the output is true, right? Anyone has any doubts in this logical AND and logical OR operator?
Yes, I got a question.
Yeah.
I understood
Please.
the operators, but you started saying Boolean flag is equal to false. Why you started as it being false? If you make it true, will the equation be changed?
No. See, Boolean, even if I don't make this Boolean flag equal to false, right? So Boolean, any data, so I'll let you know one thing. So every data type has some default values. Like Boolean's default value will always be false. But even if we like make this true, right? Then what will happen is like, and let me like make this double equal to ampersand. So what we basically do are trying to see is like if x is less than y and a is less than b, flag equal to true. So I won't be able to demonstrate you the thing right here. What we, the issue will be like, it will still show me true. Why? Because what happened, Boolean flag was set to true by default, right? At line number 15. Now when I went ahead and tried to execute this condition, this is basically returning me false. So it did not even go and execute the statement at line number 25. Got it? But the condition, the control comes out of this. This statement at line number 25 did not get executed. But we know our default value was set to true, right? So we are printing the same value here. So that will obviously return me true. It is not the value which got modified at line number 25 because one of the conditions here is false. But whatever flag we had true, so that automatically got printed. So to demonstrate my example, I needed to like make this as false. Is your dot clear?
Yes, thank you.
Yeah. Anyone else has any questions in this? Okay.
This is the statement is given as false, right? I mean, the Boolean float is false. The statement is true. It's making true, right?
Which can you please let me know the line number? Which
Yeah,
statement?
for example, second one is x greater than y.
This one?
And no, first one is true, right? No, first one. Yeah.
Okay.
X,
You
no,
You mean to say you are talking about line number 24 to 26, right?
So the 19, like 19.
Okay, 19. Yeah.
So the statement is true. I mean, because we give out X and Y.
No,
and the
see, now the statement is not true, right? See, double ampersand is used to basically return true. Means this is logical AND operator. Logical AND operator will return true only when both the conditions are true. So now if you see condition 1, X is less than Y, this is not true, right? Because I have like my X is 25 and Y is 20, right? So this condition is not true. So
Oh, yeah.
this condition is false and
Mhm.
this condition is true. But you know that both the conditions need to be true in order to return true for
Yeah,
this
right.
double ampersand. So this is true, right? It's this is false and this is true. So this will altogether return me false, right?
Yeah, it
So
can be one. The end is one of true, and one is false.
yeah, at line number 24 to 26, this is logical OR operator. So how logical OR operator basically works is like if any of the conditions is true, if either the first condition is true or the second condition is true. So basically this entire condition will become true. So that is how we basically this line number 25 is executed. Let me write down some comments for you, like logical and so logical and is basically double ampersand. So
If you one of three, this not false.
condition 1 is true and condition 2 is true.
Next true. Okay.
So it will return me true.
True. True. Right.
So again, we go ahead and write down the same for logical OR. Logical OR is basically double pipe symbol. Condition 1 is true
One is false. You can say that.
or condition 2 is true. Means any of the condition have to be true. Even if both the conditions are true, it will still return true.
True.
Means see, in this case, right, at line number 24 to 26, even if like both the conditions are true, this will still return true. The condition for this to be true is like at least one of the conditions need to be true. So even if condition 1 is true or condition 2 is true, this will return me true. Any questions, anyone?
So even if it is more than 2, we can say if all conditions are true, the end logic will be true only on only that with that condition. Then the
Sorry, can you
or
come ahead?
the OR logic will be false only if all conditions are false. Is that right?
You are talking about logical OR operator, right?
Yeah.
Yeah. So when we have logical OR, so we basically just need one condition to be true. Even if like other all conditions are false, it would still return me true. Means at least one condition needs to be true. If it is true and rest of the conditions are false, that will still return me true.
Which means it will be false only if everything is false.
Yes, yes, correct, correct.
Thanks.
Yeah, one more thing. I have just demonstrated this with two conditions as of now, right? Like x less than y and a less than b. So these are basically two conditions. Now I'm trying to like expand this. Means I will just extend this. I will just create two more variables and t is z equal to 30 and t p equal to 28. So what basically I'm trying to do is like, I will try to extend this. I will try to just have P less than Z, and I can set some flag values. So basically my intention of demonstrating this is like, you just don't uh, get confused, like you will be able to have only two conditions over here, but you can have like conditions more, means you can have like multiple conditions when you try to use this AND operator and OR operator. So you can have like condition 1 ampersand, condition 2 ampersand, and then dot, lot of conditions you have written, and then condition n. So means you can basically have like number of conditions. You can like write 10 conditions, 20 conditions, 30 conditions, whatever you want to write. So that is what I'm trying to demonstrate. You can have like n number of conditions when you are using logical AND and logical OR operator. Got it? Okay. Let me go ahead and start.
Prita,
Yeah,
can I interrupt the comment? Yeah, I have one question.
yes.
I'm clear from the if condition, but still I confused from flag statement. You know, for the first,
Can you
we
let me know which line number you are basically speaking about?
I'm not identify the line. Just I need to Boolean enter flag statement. You know, we have the default flag statement for the first line 18.
Okay.
And also we have the flag statement with a condition. So when we get the result, the default flag condition. But as this statement, you know, this condition is the logic is when is or either of one, it is we get the result, it is true. But if it is both of false, false. And also the first statement is end logic. And logic either both of true, is that is true, or one of false, false, that is the logic. But when we get the result, default flag statement.
Mm. Okay, so I did not basically get your question entirely. Means you want to get the default flags value? Is that what
Yeah,
you
when we get from this statement,
Okay,
the first
yeah.
line 18 is default flag statement. Yes.
Yeah, so 18 is basically assigned a value false initially. And so see, what happens is like, I'll comment out this entire thing, so that let me comment out this entire thing. So we are just talking about line number 22 to 24 now. This rest of
18
the,
and
yeah, I'm coming to that. So you can see line number 18 has flag value false, right?
yes, this is the default.
Yeah, and we are trying to execute these two statements. If x is less than y and a is less than b. So we already know that double ampersand basically checks both the conditions or
Yes.
all the conditions, right?
All the
So if x is less than y, which is basically false, right? So we know that this statement will not be executed, and now you will get the output as false. So basically when this condition is false, it won't check this condition, right? And when this it won't check this condition, so basically this statement will not be executed. So your flag value was not modified. So whatever default flag value you already have, so that will be printed. So in this case, when you come and print your system.out.println at line number 42, this will basically return you false. See, you're getting the output as false, right? Is your question, is your doubt clear?
As a statement, yes, I'm clear. But when we use a real time project, that is, we have the default flag statement, and also we have the if condition with the flag true. So that time, how do we expect it?
See,
The-
when you make some real-time project, right? So basically, how you want to write down the conditions, that basically depends on you, right? So your if conditions, what whether they are returning true or whether they are returning false. So basically, initially what you can do is like you can have your Boolean flag to true or false, means you have to like just analyze a bit like what type of conditions you are going to write. Suppose you want to check whether some flag's value is getting converted to false at some point of time in your code. So you can like set your initial default value to true because you want to check that whether that true got modified to false at some point. So initially you can like assign true to that variable boolean flag equal to true. So if you want to check whether my flag value got modified in code and you want to see that whether that false becomes true, so you can set the default value to default value of the flag to false, and then you can like write down some conditions and check whether that particular flag's value basically modified to true or not or false. So that is how you can write. Is that clear?
okay, thank you.
Yeah. So we'll go ahead with some other operators now. We have covered this logical and Boolean operators. So I'm trying to show you some bitwise operators, and bitwise operators are basically like uh, the operation between the bits. And you know that computer or the program that we write internally, it computes on the binary numbers, right? And binary numbers are basically like 1 and 0. So 1 is basically like true and 0 is basically false in terms of binary. So whatever decimal numbers that you write, right? So suppose you are writing 1, 2, 3, 4. It has a binary number representation as well, right? So suppose this is a simple pictorial representation of like what the binary equivalent of number will be. So if you see this line number, if you see this 14, right? And you see this base 10, right? So this is basically 14 in decimal is equivalent to 1110 in binary. So whenever you see this base 2, right? So that basically shows you what type of number it is. This is like a binary number. So binary number will have only two values, either it can be 0 or it can be 1. And when you write down this base 10, right? So this basically means like it will have your numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is basically our uh, decimal numbers. In decimal numbers, you basically, when you see this base 10, it represents all your whole numbers, natural numbers, and all those things. So you can convert this to binary numbers. So we will not go and see like what basically how we basically convert. I'll just let you know on a high level how the decimal number gets converted to binary. So see, you're seeing this first picture on the left hand side, right? Where it's written let the decimal number be 14. So you basically like divide the number each time by 2. So when you divide the number 14 by 2, so it would be 7 times 14, right? So you see 7 over here and it's fully divisible. So this is like 0. Again, you divide 7 by 2. So what happens is like you can like divide it max by 3 times. So 2 into 3 is 6, and there would be a 1 remainder. So 1 is written over here. Again, you divide 2 means 3 by 2, and then you get a 1 as remainder. Again, you divide like 1 by 2. It will not be divisible, but it will show you a remainder. And then, so this would be, and whatever remainders you have got, you have to like basically take those in the reverse order to get your binary representation. So this is on a high level how the decimal number gets converted to binary. But yeah, if you just want to check more on this, you can go ahead and check out some YouTube videos how decimal to binary conversion takes place. But I've like demonstrated you this way. Every time you divide the number by 2, and then whatever remainder you have got, it will be written on the right hand side. Again, whatever values was left, again you divide it by 2 until you like reach 0. So this is like converting decimal numbers to binary conversion. Why? Because I'm showing you this is every decimal number can be represented in the form of a binary number, and binary number will be like basically in the form of ones and zeros, and there are like operations on those as well. So those are called like bitwise operations. So now, sometime back we saw what double ampersand works, right? Double ampersand is basically checking whether condition 1 and condition 2 and condition 3, like all the conditions are true or not. Now there's a bitwise AND operator. So how bitwise AND or bitwise OR operator works is like it works on every bit, and it works like one, suppose you have two numbers in binary and you want to like basically check how and you want to basically perform the bitwise AND. Let me go and show you this one. See, you have two decimal numbers, 5 and 4. And okay, let me create one demo example for you. So you have like two numbers, 4 and 5. So 4 would be equal to like, it would be equal to 100 in binary, and 5 would be equal to 101 in binary. And when I want to say like 4 ampersand 5, so this basically is equivalent to 100 ampersand. Okay, let me just write it below this one so that you can understand how basically this would work. 4, then you write down 5 here. And how this would basically compute is like, you see this 0 and 1, right? At the end, I'm taking the numbers from the bits from the end side, like 0 and 1. So if both the numbers are 1, only then it will like return a 1. So you can see that in the first number, the last number is like, I'm comparing the last numbers now. If both the numbers are 1, it would be 1, otherwise it would be 0. So this is 0. Again, the first bit is 0. The second bit is also 0. So this would be 0. Now you see that the first bit is like 1 and the second bit is like 1. So now this would return a 100. So this is basically returning me 100. Everyone got how we reached until this point? Hello?
So you are saying only
Yes.
it will be 1 only if both are 1.
Yes.
Is that right?
Yes. If both the bits are 1, only then it would be 1. Otherwise, it would be a 0. So this is for AND operator, like bitwise AND. So similarly, see, AND means like all the conditions are true, or means like even one condition is true. So similarly, if I write this, change this to on, means this OR operator, right? So even if one of those is like 1, it would return me a 1. So that is the case. I will show you again for this one. Let me demonstrate another thing for you. I am demonstrating bitwise OR operator. So this would be basically, see, 0 and 1. Even if one of the bits is 1, this would return me a 1. Only when all both are like 0, it would return me a 0. And then if both are like 1, this would return me a 1. So are you able to like get this until now? Let me go back to the slide. See, let's read it out, this slide. The bitwise operators apply only to integer types and perform their operation on each pair of bits in two operands. So see, the AND operator. AND operator means here bitwise AND means a single AND ampersand operator. It's a single ampersand. So it will yield a 1 if both bits are 1. So example 5 and 4 results in, see, this 0 1 0 1 is 5, 4 is basically 0 1 0 0, and it results in 0 1 0 0. Only why? Because only the second bit in both the numbers are basically 1. So it results in 1. Let's go to the OR operator. The OR operator yields a 1 if either bit is 1. Like even if like at the corresponding position, even if one of the bits is 1, so that will lead to the result 1. So you can see that at line number means the second and 4 bits in the first number are basically 1, right? And the second bit in the second number is 1. So that will basically lead to 0 1 0 1. Similarly, we have like other operators as well. So there's a XOR operator or XOR operator that we say. It will yield a 1 only if two bits have different values. So this works in a different way. Like if the first, suppose you can see like at the last digit, the last bit you can see right here. The last bit is 1 in this number. And the last bit is 0 in this number. So you see that the corresponding bits are different. So only if that is the case, then that will be like true, means 1. So read out the definition clearly and you will get it. Like the XOR operator yields a 1 only if the two bits have different values. 5 and 4 results in 0 1 0 1 and 4 results in 0 1 0 0. And which is the position where you see that the bits are different? It's only at the last bit, right? because it is 1 in first number and 0 in the next number. So that will basically return to that will basically yield a 1. Now what is
If
basic?
both is similar, if both is similar, we will take to 0, yes?
Yeah, if both the bits are like same, then it will be 0. You can see, right? The first bit in both the numbers are basically 0. So it yielded a 0, right? Then both the bits in the first number and second number are basically 1. So that also led to 0, right? So only if both the bits are different, it would lead a lead to the bit 1 in the result. Read these definitions out, means in the slides that I've shared with you already, right, in the Google slide, these are already updated. So basically you can just read it once more. If you read it carefully, right, you will get it. These are like straightforward things. These are sometimes these are not very favorite for interview questions, but I am just teaching you because these are part of concept. Means sometimes questions based on this are asked in some algorithms, but those would be like very means companies which ask very complex questions on bitwise operations. Sometimes you may get some algorithmic questions, but we are not going into that. These are basically less asked in interview questions. uh, Sometimes you may be asked, but as part of like Java concepts, I will teach you all this. Then we have like this complement operator. So complement operator, basically what it does is like, if your if the bit is 0, it would turn it to 1. If your bit is like 1, it will turn it to 0. Means 0 changes to 1, 1 changes to 0. So if you see this number 0101, it basically changes to 1010. So let me just show you some examples over here. So let me show you first bitwise AND. So we are doing a bitwise AND, and then what I'm basically doing is AND 100 and 101. What would be the output? Can anyone guess over here? I will write down all the questions here, and then I'll ask you the output, bitwise or
4 and 5, right?
so
101.
no, see, this is
Oh,
like 1 second. I would write 4 and I would write 5 here.
5, yes, that's
But 4 and 5 are basically like I'll just write 4
Sorry,
is like
101.
100 and this
101.
is like 101, right?
right.
But one more thing, like these operations are again like at, let me try to execute this and I'll show you. This returned me 4, right? Because what it basically returns internally is like, it will return me 100 again, right? Anyone has any questions? Means 100 and 101 will basically return you 100, and whatever the equivalent of this is there in decimal, that will be basically returned to you as the output. So we already know that 4 has a binary equivalent to 100, so 4 will be returned, right?
Like
Got it?
like double and flat, like that's you have to took the flat one under.
No, not
Under
let's
float,
not get confused with double and float now. These
just
are, let's not like bring those two concepts together as of now. See, what is the equivalent of 4 and 5 in binary? It's like 100, means 100 and 101. So internally, the bits, how this worked was, it provided me a result of this 100 and whatever the decimal representation is for this, that will be like returned to me as the output. Similarly, if I go ahead with 100, sorry, 4 and 5, ampersand 5. So again, this is basically 4 and ampersand 4 by 5. So we have like, what would be the output? Like this would be 1 at this position, and then this would be 0, and then this would be 1. And we know that this is the representation of 5, right? So
Mhm.
this would basically return me 5. Let me try to run this one. So this is basically returning me 5. Now let me again go with bitwise OR XOR basically. And this is the symbol of XOR. This is like caret symbol that we are using for XOR. On your number keyboard, if you if you see the number 6, above that you have the caret symbol, right? So basically that is used for this XOR operations. So you can see at this point, like it would be 0, because only when the bits at the corresponding position are different, it leads to 1, otherwise 0, right? So 1 and 1 are same, so it will be 0. 0 and 0 are same, so it would be 0. And 0 and 1 are different, so this would be 1. So this is basically 0, 0, 1 in decimal is basically 1. So if I run the program again, I would get like 1 at the end. So next is like complement operator. So complement operator is like, you basically have this operator, and I'm using it in front of 5. So basically this is like in front of 4, so 100. So when I make this 100 as complement, so this would be basically first
0, 1, 1.
1, yeah, 0, 1, 1.
0, 1.
So 0, 1, 1. So this is basically the representation of 3 in, means 0, 1, 1 means 3 in decimal. So basically if I run this, 0, 1, 1 basically okay, 1 second. Complement 4, it returned me a 5. Results in, okay, 1 second. 5, if I take 5. No, the third was 0, 1, 1. If I make this 0. No, there's something wrong.
I think when you started it was wrong. The first number, the 100.
Okay, 1 second.
That should be 1, 1. Yeah.
0, 1 and 1, 0. Okay, this would be like 0, 1, 0, 1. And after conversion, this would be like 1, 0, 1, 0. And if I, okay, 1, 0, 1, 0. Okay. Okay, I'll come back on this one. Maybe I'll check this one and I'll come back on complement operator later. But XOR operator and OR and these are like clear, right? I'll come back on this complement operator in some time. So Yeah, there are some more operators in this bitwise operators. So there are like shift operators, left shift operator, and then like right shift operator as well. So what this basically will do is like this will multiply the number by 2, and this would basically divide the number by 2. So if I write down something like 4, 2, so this would basically return me 8. Okay, 1 second. No, I need to make it like 1. Now this is returning me 8. So see, what this basically does is left shift operator. If you see at line number 33, so if you move the bits by 1, so this will be like basically multiplied by 2 one time, multiplied by 2. So if you like again,
I
like
cannot see 33, Pritam. I
sorry,
cannot see I cannot see the 33. It's hidden.
no, you cannot see line number 33.
Yes, drag it up, please. Drag it up.
Other people, can you see it?
Now I see that you can wrap up.
I think your need to move your screen. I can see it.
Can you? I think everyone else can see it. Can you please adjust
Yes.
your screens?
For me, I can see your screen.
Mm.
Other people, can you see it? I think you have issue. Means, can you try to maximize your Zoom window?
Okay.
Yeah. Okay. So what I'm basically trying to say is like, see, if you means this left shift operator, double left shift operator, right? If you have this shift by 1 bit, so that will basically change, multiply the number by 2. Again, if you like shift the bits by 2, it would basically multiply by 2 into 2. So 4 into 2 into 2 will be 16. Now again, if I make it like by 3 times, right? Again, it would be like multiplied by 2. So it would be 32. Again, if I make it by 4, it would basically get multiplied by 4. So it is 64. So similarly, if I use a right shift operator, if I do a right shift operator by 1, so this will be basically divided by 2 one time. If I again do it by 2, so it would be divided by 2 into 2. So this would basically give me a result of 1. You're able to see the result 1, right? At the end, this one. So this is how it works. It basically shifts your bit, every bit. So let's come and see this slide. A single left shift will multiply the number by 2. And if you use like double left shift, means if you shift it by like 2 digits, so it will like multiply by 4. If you shift I left shift by 3, so it would be basically multiplying the number by 2 into 2 into 2. So the number of shifts you want to do, that many number of times you will have to be like multiplying by 2. And similarly for right shift, it will like divide the number by 2.
Mm.
You got it, right? And then we have something called like unsigned bit shift, right? So where we basically use this 3 arrows. So this operator is not very popular, but sometimes you may see this at some point of time, but this is not very operator. So this is not very popular. This operator basically works same as that of the right shift operator, and means what right shift operator does is like it will basically divide the number by 2, right? And so only difference is that it does not preserve the sign bit. So what we mean by that is like whenever a number is shifted to right using the normal right shift operator, the bits on the left are filled with the value of the sign bit 0 or 1. But in case of the unsigned right shift, the left bit is always filled with zeros. So what happens is like on right shifting, right, how it internally works is like right shift is basically like moving the bits to your right. So one, if you basically see, right shift means like this 1 would basically come at the second position, this 0 will basically go to the third position, and this the bit at the third position will basically go to the fourth position. Internally it works like that, and all the bits on the left side, right, that will be like changing to zeros. So that is the thing. Means I'm not going into so much complexities because this topic is like a little less asked, and anyways you have the overview as of now. And this bitwise unsigned bit shift operator, right, triple arrow, this would work similarly in like how this bitwise right shift operator works. It's just that on the left hand side all the bits will be zeros. Even if you like do not understand this unsigned bit shift, right, you may like ignore this as of now. This is not that popular or not that important as of now. Anyone has any questions before this? You got to understand, right, how these bitwise operators work. It operates on the binary representation of each of these numbers. So every decimal number can be represented in the form of binary. And let me like just revise all those. AND operator will only return 1 when both the bits are 1. OR operator will return 1 if either of the bits are 1. At least one of the bits, if it is 1, it will return 1. XOR operator will return 1 only when both the bits are different at the corresponding position. And complement operator will basically turn zeros to ones and ones to zeros. And then this is left shift operator. Left shift operator, if you like shift it by 1, it will multiply by 2. If you shift it by 2, it will multiply it by 2 into 2. Similarly, for right shift operator, it will divide the number by 2. If you shift it by 1, if you shift it by 2, it will divide by 4, and so on. Got it? Okay, we'll see one more thing. I think we are already okay. I'll complete this 2 slides as well because we want to start a fresh topics in the next class, and that would be like looping. That would be very important as well. So I think I already showed you this promotions and demotions rule, right? Earlier, the previous class, I have shown you this slide. So basically promotions and demotion rule is like which all data type can be like converted to what. So you know that double is a data type which is like basically having more storage than float, right? And similarly, long data type is having more storage than your integer, byte, or sort. We have already seen examples on this. We have seen demos as well, right? I think we have seen these examples, right? Byte, sort, int, long, how we basically have this, and we also saw this example, right? Volume.java, when we were trying to like change float to double and double to float. Sometimes we were getting compile time error because we were getting compile time error, right? Because double cannot be like changed to float because of like higher data type cannot be stored to lesser data type. So we have like already seen these concepts, right? So this slide was basically related to that. Can anyone tell me like what was the concept of typecasting that we saw in the previous class? If anyone has gone through the last classes topic, so can anyone tell me like what we discussed in typecasting? See, we basically discussed one thing, right? Means if you want to basically convert your uh, double to float, that means higher storage data type to lower storage data type. Generally, you cannot do that because that will throw you a compile time error. But at line number 33, right, you can see this explicit conversion of double into float. What we basically do is like we forcefully or uh, we try to typecast this with float, and then this would basically get converted to this double will be converted to float. I think we discussed this one, right? Last class. Can anyone recall this?
Yeah, okay.
Yeah. Okay. Yeah. So this was about the typecasting. So similarly, this is like promotions and demotions rule. I think I already showed you this slide last class. So see what this is basically doing is like, let's see this example. Float b equal to, they are taking some float values, right? This is float b, and then this is c, 1.2f and 3.4f. So what we are trying to do is like, we are trying to divide this here. Are you able to see this line? Int a equal to b by c. But b by c will return me a float value. And what I'm basically trying to store, how I'm trying to store is like, I'm trying to store in a integer value, which is basically a lesser data type than float. So if you try to like store any data type in a lesser data type, that will throw you a compile time error, right? This we have already discussed. So in order to like get only the integral part of that thing, what we basically do is like, we divide this and we basically forcefully typecast this one. This is again using the concept of typecasting. So if you divide two float numbers, the resultant should be a float number, right? If you divide two double numbers, the resultant would be a double number. So ideally, you should store those things in your double or float data types. But somehow you just want to get the integral part of those values, right? So what you will basically do is like, you will typecast that to integer like this. Are you getting this?
So that means exclude the decimal points and give me integer.
Yes, correct. So integer basically stores your integer values only, right? So it will exclude your decimal values and it will just give you the integer part. But see, float and double, these are like storage data types which are like in the higher, they have like more higher storage than integer, right? So that is why if you just divide two float numbers and try to like directly convert to integer, means store it in integer, this will throw you an error, right? That will be a compile time error. So what you want to basically do is like typecast this. Whenever I say by typecast, you basically have to like convert this forcefully into the lower data type. So this is how we typecast within within the small brackets. You just provide the data type of the smaller data type which you want to basically convert into. So this would be converted to integer, and it will exclude your values after the decimal part. You will get only the integer data type. Is it clear?
Is it always true, or
Sorry.
is it always true? So if the example one, int a is equal to b divided c, it will getting for compile time error.
See,
But it is yeah, it is always true, or some types maybe will respond true. So
no,
why we
it will
getting
always
for
give.
compile time error?
See, it will always give you compile time error, right? See, you are trying to like divide two float numbers, be it any number, because float cannot be directly converted to integer, right? This is what we discussed last class, right?
Yeah,
I
if it's float, yes, I agree. But
Yeah, then see, these are two float numbers, right? Float B and float C. And what you're trying to do is like you are trying to divide these numbers B by C. So that will result in a float number, right? And you cannot directly store a float number to a integer, because float, if you see this, right? If you see this promotions and demotions rule, float is basically above this integer, right? Integer is here, float is here. So you can store this float in a double, but you cannot store float in an integer directly. For that, you will have to do that typecasting. Is that clear? Okay, I'll show you again with an example. See, float y equal to 10.9f. Float z equal to 11f, right? Now, what I'm trying to do is like I want to divide these numbers. So let me show double x equal to y by z. Now you see that this did not throw me any error. Why? Because double is a higher data type than float, right? So this can be like easily converted to double. Means a higher storage, understand like this. If someone has an iPhone which is like 128 GB of storage, it can definitely take any file or store it. Suppose that file or folders or drive size is like 64 GB. Your phone can accommodate that, right? Because you have like higher storage capacity. But say if your phone is like 64 GB and you want to store some drive contents that is like 128 GB or let's say 500 GB, you cannot store that, right? Because that is like a higher storage capacity, and your phone does not have the capacity to store that. So similarly is the concept here. Double is a data type which has like higher storage. That is why it is like able to store this float. Now similarly, if I try to like store it in an integer p equal to y by z, this will give me an error. See, I started getting this error, right? Because, and you see, you are also getting a suggestion cast to int, right? So if I click on this editor will give me some suggestion. If I try to like click on this, so this will do that typecasting for me. Now it is okay. Now we are getting the only the integer part of this y by z. So we are able to get the integer part. So this is called typecasting. Is it clear now?
Yes, thank you.
Okay. So we'll keep the class to this, and with this we are done with operators. We have seen bitwise operators, we have like seen conditional operators, we have seen assignment operators, we have seen decrement and increment operators. So we'll start with looping constructs tomorrow, and we'll go ahead with like for loop, while loop, and do while loop as well. If someone, I've already shared the slides for this in that Google slide. If someone has some time, so you can go ahead and just go spend some time uh, in going through the looping constructs, because loops are very important, and we'll cover this concept tomorrow. And also whatever has been already taught to you, so you please go ahead and try to revise that, and try to do some kind of like hands-on on those, such that you do not forget the concepts going forward, because there will be like lot of concepts which will be like taught to you in the next classes. Okay, anyone has anything to share, or like we can conclude the call? Okay, then we'll meet. Sorry. Yes, I can hear you. Yeah, please go ahead.
Please share the video after the class.
Yeah, I'll upload the videos. Maybe I'll try to like upload by today, or maybe tomorrow. I'll upload the videos and share. It means the same YouTube channel, right? You'll start getting the videos. I think for the last class and today's class, I've not uploaded the videos. I will try to like upload it by today or tomorrow.
Okay, cool. Thank
Yeah.
you.
Okay. Okay, then we'll see you all tomorrow at the same time.
Right.
Yeah.
All right. Good night.
All right, thank you.
Yeah, I am
Good night.
speaking.
Yeah. Please go ahead.
Yeah, so for this ID Eclipse for IntelliJ, so can we have like different projects? Like when I compare to Eclipse, I
No,
can
no. So,
offer like three or
okay.
more.
So what you're basically trying to, are you using Eclipse?
I used to use Eclipse and then I can create different projects on Eclipse, but when I try to, how do I open like 2, 3 projects on IntelliJ?
No, you can open multiple projects on IntelliJ as well. There's no issue in that. You can open multiple projects in IntelliJ as well. So when you try to open, go on new and then open the project, right? So you will be asked like whether you want to open it in the same window or in a new window. So you will get the options. You can open multiple projects using IntelliJ also. There is no issue in that.
Yeah, but when I open different projects, so the previous project will be hidden,
No,
or I can.
no. All the projects will be like there, and you can basically try to use the practice, like try to open projects in a different window, so that whatever projects you want to execute, you can like execute.
That's from the window, and then I'm gonna use.
Can you share your screen as of now and show me like what exactly you're facing the issue?
Okay, so
Prima. Do you suggest EDABIT for practice?
Sorry,
Do you suggest EDABIT, EDABIT for practice?
what is this EDABIT?
Like it's a practicing website.
I am not aware of this EDABIT, but whatever I'm teaching you, right? If you go ahead and try to like follow those things, and you follow the slides, right? I think that should be more than sufficient, because I'm like spending more than enough time. I think anywhere else like you won't be taught at this slow pace. I think I'm trying to like cover you all the concepts. So whatever classes you are being taught, right? I think if you go and just revise those concepts and try to do those hands-on, right? I think it should be quite good. Yeah, if you have some other reference materials, you can go with those as well, but try to like see if those contents are proper, because it should not be like if those contents are not proper and you start getting confused. So that's why. Yeah, please, teacher, yeah, what was your problem?
So my question is, for example, if I want to open like for Eclipse, like I can see like this batch one project, right? So for
No,
example, if I
can
want to
you,
batch
ca-
two, I
yeah,
have
can you
like,
go to that file? Can you go to that file option at the top?
Mhm.
Yeah, yeah, new project.
Yeah,
Just
so
click.
I'm gonna click project, but it's gonna be hide this one. For
Sorry, what?
example, batch two. For example, if I create batch two,
Create. Do a create.
yeah.
Either you can open it in this window or another window.
So I don't I can't see the previous one.
No, you switch tabs. It is open for you. It is all the projects are open for you. Batch one is all. Just go ahead and click on your IntelliJ icon on the. Uh, no,
Yeah.
no, not there. Can you
Bottom.
hover on the bottom? Can you go ahead and like wherever your IntelliJ is, right? I'll show you.
You wanna see it?
Yeah. Okay, it's not opening for you.
I can open here.
Okay, 1 second, 1 second. Okay, do one thing. Close both the projects. Close the IntelliJ ones.
Okay. Exit.
Yeah, exit. Open IntelliJ again. Okay, batch 2
So
is
I
opening.
can't see batch
Okay,
one.
yeah,
I can't
1
see batch
second.
one.
1 second. Can you go and on that file? Let me stop the recording. This is not relevant to today's class. So I'll stop the recording.
Okay.